Henry Moseley. In the year 1914, Henry Moseley, a British physicist, investigated the X-ray spectrum of elements. He plotted a graph of square root of the frequency of X-ray from the elements against their proton number. A straight line was obtained. The proton number should be used as the basis for the periodic changes in the chemical properties of the elements. Therefore, Moseley arranged the elements in increasing order of their proton number. He produced a periodic table similar to Mendeleev's periodic table. In Moseley's periodic table, he confirmed that tellurium must be placed before iodine and cobalt must be placed before nickel, as predicted by Mendeleev. Hence, Moseley was successful in developing the periodic table based on the arrangement of elements in ascending order of their proton number. Modern periodic table. In the modern periodic table, elements are arranged in the increasing order of their atomic number in the form of a table having 7 horizontal rows of elements called periods and 18 vertical rows of elements called groups. Description of periods. The number of elements in any period is fixed by the maximum number of elements that can be accommodated in the periodic shells, which is given by the formula 2n square when n is the number of given shells starting from the nucleus. There are 7 periods of elements are as follows. First period has 2 elements, hydrogen and helium, called very short period. Second period has 8 elements, that is lithium to neon, called short period. Third period has 8 elements, that is sodium to argon, called has short period. And the fourth period has that 18 elements, potassium to krypton, called long period. Fifth period has that 18 elements, rubidium to xenon, called that long period. And the sixth period has 32 elements, that is cesium to radon, called very long period. And the seventh period has 28 elements from francium to that atomic number 114, called incomplete period. 14 elements each of the sixth and the seventh period are placed separately at the bottom of the table. The 14th elements of the sixth period from lanthanum to lutetium are called as lanthanides, and the 14 elements from the seventh period from that is called actinium to that laurentium that we called as that 14th one and are called as actinides. Description of groups. Elements of group 1 and 2 on the left and the groups 13 to 18 on the right are called as normal or representative elements. Elements of the group 1 are called alkali metals and those of group 2 are called alkali earth metal. Those of the group 13 are boron family. Those that group has 14 as the carbon family and the 15th group has called the nitrogen family and those of 16th group called as oxygen family, 17th halogen family and 18 is the inert gas or noble gases. There is a subgroup that is A subgroup elements are called that normal elements and the B subgroup elements are called transition elements. Lanthanides and actinides are called inner transition elements. So group 1 that is first A elements are called alkali metal. Group 2 that is second A elements are called alkali earth metal. Group 17 that elements are called halogens and the group 18 that is zero group are called as noble gas. In a group all the elements have that same number of valence electron. Group 1 element has 1 valence electron, group 2 has that 2 valence electron, group 3 has 3 valence electron. In a period all the elements contain the same number of shells. Properties of elements in periods and groups. Valence electron, which is called as the outermost electrons. In a period that the number of valence electrons that increase from 1 to 8 from the left to the right and the number of shell is the same. In a group, the number of valence electrons is the same for all the elements but the number of shells increase from top to bottom. Valency. Valency is defined as the combining capacity of an element. It depends upon the number of electrons present in the outermost shell or valence electrode. In a period, the valency of the elements increase from 1 to 4 and then decrease from 4 to 0 from the left to the right. but in a group the valency is the same for all elements of the group. Atomic size, the size of the atom, and the factors which affecting that atomic radii, that are effective nuclear charge and the number of valence shells. In a group, the size increases from the top to bottom due to the formation of new shells. But in periods, the size decreases from left to right due to that effective nuclear charge. Exceptional in periods, the halogens are slightly smaller than noble gases, since noble gases have completed octet. Atomic size does not increase much when we move from aluminum to gallium due to that poor shielding of inner core of electrons. Ionization energy, and it is also called as ionization potential. It is the amount of energy required to remove one or more electron from the outermost shell of an isolated atom or in the gaseous state. In a group, ionization energy decreases with the increasing atomic number. In period, the ionization potential increases according, that means across the period, because the increase in nuclear charge due to which the atomic size decreases. Thus more energy is required to pull away the electrons from the outermost shell of the atoms of smaller size. Here that exceptional, that is nitrogen oxygen, through that ionization energy that increases along the period, and nitrogen has more ionization energy than oxygen because nitrogen is already half filled and more stable. Electronegativity, the tendency of an atom in a chemical compound to attract shared pair of electrons to itself is called electronegativity. In period from left to right, the value of electronegativity increases, while down a group, the value of electronegativity decreases. Metallic and non-metallic characters. Generally, metal possesses 1, 2, or 3 electrons in their respective valence shell and thus have a strong tendency to lose electrons to form positive ions. Therefore, metals are also called electropositive elements, and the metallic character is also called electropositive character. Non-metal, on the other hand, generally have 4 to 8 electrons in their respective outermost shells and thus have a tendency to gain electrons to form a negative ion. Therefore, nonmetals are also called electronegative elements, and non-metallic character is also called as electronegative characters. In that means metallic characters will be increased along the group or it will be decreased along that period, and non-metallic characters will decrease along the group and increase along that period.